Assalamualaikum warahmatullahi wabarakatuh. So now we move further to more complex analysis in macroeconomic study, and we are going to look at the monetary and also fiscal policy. And this time around, we are using a bit more complex model. In particular, because in the previous example, for instance, if you can recall back chapter 1 and 2 and also chapter 3, you can see that the determination of equilibrium income, we have assumption where interest rate was constant. Well, we only want to look at what happens to output in the economy. But this time around, we relax one assumption in which we relax interest rate. So we allow flexibility in interest rate, and we analyze what happens to equilibrium income and also equilibrium interest rate if we allow either monetary or fiscal policy to occur in this, in this economy. So it's a simple model, it's a closed model, but then it becomes complicated because perhaps if you are very weak in mathematics, then you find it very difficult. But anyway, when we talk about the government economic policy, we have first monetary policy and fiscal policy. So in this lecture, we're going to look at the fiscal policy first, and then we look at monetary policy. Now, when we talk about fiscal policy, if you can recall back the thing that you have learned in your undergraduate level of study, we know that fiscal policy has two main tools, and those tools are government spending and also government tax. Okay, so these two can either increase or decrease it depending on the economic situation in the country. And you know that economic condition in a country, you have two things: recession and inflation. Okay, recession means output growth going down. So how do you want to increase it? Let's say you are using fiscal policy only. This is a revision, yeah? Then you can increase government expenditures, and in the middle there will be something happening in the economy, and then finally output will increase by the amount of multipliers, isn't it? So that's what you learn in your undergraduate level. Or you can also reduce tax, or you can use both. And this kind of fiscal policy method during recession is what we call expansionary fiscal policy. So of course the opposite is contractionary fiscal policy. Okay, the reverse of it. And the reverse of it is utilized when we have inflation. And if you look at G, this is real G, the small letter. Government spending, you must remember, is a direct component of aggregate expenditure. Now, from aggregate expenditure, I did use Likation injection approach, or you can also use aggregate expenditure approach to derive IS curve. And because government expenditure is a direct component of aggregate expenditure, therefore it is also a direct component of IS. Recall back IS is basically equilibrium position in which y equals to c plus I plus g, isn't it? So you can see clearly in equilibrium position, IS has component of government spending. Alright? And tax here affect this equilibrium via consumption. Why? Because this consumption can occur only after you pay tax for your income. So you have disposable income. consumption depends on disposable income, and assume that tax here is a function of y. But if you can recall back in the undergraduate level of study, your tax here is a lump sum tax that doesn't depend on the level of income. But at the higher level of study, at the postgraduate level of study, we will relax this assumption. You will see later when we introduce fiscal policy to find what happens to equilibrium output and also equilibrium interest rate if we allow tax to change, because it's a tool of fiscal policy, or G to change. Okay, all right. So we begin with fiscal policy first, and then after that, once we finish with fiscal policy, we can start talking about monetary policy. So this is what I said just now. And here, in addition to what I said, G or government spending is a direct component of aggregate expenditure, and it is also a direct component of aggregate demand. Therefore, it is also a direct component of IS. Okay, on the other hand, T or tax is a component of leakage because T is a payment made by, people in the country that doesn't go to the production process. So it is a leakage. So it's not a direct component of aggregate expenditure, but it can affect one direct component of aggregate expenditure, that is consumption. Because consumption depends on disposable income, and disposable income is basically income minus tax. Alright, so that's why. Okay, now, again, I would like to repeat the tools of fiscal policy. We have government spendings and also tax. Now let's look at government spending. So we want to look at the changes in government expenditure, which is real G. So let's say we have a graph here. So we have S plus tau and also I plus G here, the level of output. So I'm gonna draw the equilibrium using leakage approach here. So let's say we have saving function and also tax function, which is this. Okay, S plus tau, or let's say I don't want to introduce tau first, yeah. Let's say no tax for simplicity. Later we can introduce tax. Okay, and then initial injection is this I plus G naught, initial G, initial government spending. So current government spending is at G naught. Okay, and this is leakage injection approach, and let's call this as A. The level of output is here, Y naught. And if we try to relate this with ISLM, we have interest rate here, we have real output here, and we have upsloping LM curve, we have downsloping IS curve, the first IS with initial government spending, and this is the equilibrium. I call it point E, and this is Y naught. Y naught here is similar to this Y naught, and we have R naught here. Okay, now, so let's say G increases from G naught, okay, to, let's say, to G1, and the difference between G1 and G naught is change in G, such that G1 is greater than G naught. Okay, then you can have that. So what happens next? This is a very undergraduate level, yeah? In the first graph here, in the leakage injection approach graph, so G naught has increased to G1. That means the injection curve will shift upward by the amount of change in G. So we shift it upward by the amount of change in G. I plus G1. The change here is change in G, which is G1 minus G0, isn't it? So the new equilibrium will be here. But if we use this method, we can only know what happens to the output in terms of equilibrium. So output has increased from Y0 to Y1. And in the second graph here, because like I said earlier, government spending is a direct component of G, then IS will shift to the right, isn't it? Because it has increased from IS0 to IS1, G1. If we maintain interest rate constant here, then output will increase from Y0 to Y1. So from point E to E prime. But this shows us this equilibrium, this much between E and E prime. So of course adjustment has to take place in such a way that when government spend, government needs to borrow money for spending. So when government borrows, government need to pay interest rate. Now interest rate is the cost of borrowing for investment, also for the private investment. So when government wants to borrow, it has competitors, and those competitors are private investors. So both of them will bid up the interest rate, the cost of borrowing, and then therefore it reaches to a new equilibrium at R1 at point, let's say A double prime here. Now because of that, output instead of increases from Y0 to Y1, it increases from Y0 to, let's say, Y2. So what is actually happening? Why there's a decrease by this much? And this decrease here is due to what? Because of the bid-up process, the bid-up process of interest rate between government and also private investor leads to the reduction in the output this much. So the net increase is this much only between Y0 and Y2. And this bid-up process leads to the crowding out effect. Government spending has crowded out private investor from investment because bidding up the interest rate, some investor cannot pay higher interest rate, therefore cannot borrow money and cannot invest. So when they cannot invest, there will be a reduction in output between Y1 and Y2. So the net increase is only between Y0 and also Y2. So these are very undergraduate level of explanation. Okay, so here we stop here for undergraduate level of explanation. Now we want to move to another more important things, which is multiplier for the change in G. In this case, if we can recall back previously, the multiplier for the change in G is very simple, isn't it? 1 minus MPS, 1 over 1 minus delta C over delta Y, and then something else, isn't it? Okay, can you recall back in chapter 3 and 4? Alright, but this time, in this, we can see that the change in income due to the change in G does not incorporate the change in R or interest rate. That means the ISLM analysis was not incorporated in this multiplier that you saw in previous chapters. In reality, when government spending changes because of expansionary fiscal policy, let's say government spending increases, like you can see earlier, based on my explanation here in second graph, interest rate will, react. Because when government spends, government needs to borrow, and then there's crowding out effect, interest rate adjusts, so that equilibrium adjusts to its E double prime and whatnot. So in this case, We want to see what happens if government spending increases, how much output can increase, okay, when interest rate is allowed to move. All right, so then if we want to, see the magnitude of increase in income due to increase in government spending because of expansionary fiscal policy, when interest rate is incorporated in the model, when the assumption of fixed interest rate is relaxed, we want to see what's the implication. And this can be done by looking at the multiplier for the change in government spending. So in order to get the multiplier for the change in government spending, we need to go through the mathematical process, okay, the derivation and whatnot. So here, because we want to incorporate interest rate as well, that means we need to incorporate IS function in which investment, the component of IS, is a function of interest rate. Otherwise, you don't have interest rate in your multiplier. We also need to incorporate money market because interest rate you cannot see on the product side only. You have to see on the money market sides as well, because interest rate is the price of, money in money market. Alright, so we combine IS and LM in equilibrium position, do some mathematical operation to get multiplier of for the change in G when interest rate is allowed to be flexible in the system or in the model. Alright, so how do we do it? So before we proceed with mathematical operation, I'll bring equation 1 and equation 2 in this page so that we can always refer to it when we do the maths. So what do we need to do here is that, remember we want to derive multiplier for change in G when R is incorporated in the model. So because we want to have R incorporated in the model, so we need to use equation 1, which is IS relation or curve or equation, and we also need to have LM. So IS is on the product side, and this one is on the money market side, equilibrium in money market. Alright, so what do we need to do? We need to differentiate equation 1 or IS equation, okay, totally. So totally differentiate 1, then it yields something like this. But this time, before I proceed, I forgot to tell you this very important thing. This time we have tax as a function of income. Okay, we have tax as a function of income. It's not a lump sum tax. So if we totally differentiate IS, by now you should know how to do total differentiation. On the left hand side, y becomes dy. And on the right hand side, we have consumption function. Partially differentiate consumption function with respect to y. And then in the bracket, totally differentiate y. Partially differentiate tax with respect to y, and then multiply by dt, close bracket, and then delta I over delta R der, and then plus dg. Alright, so let's call this one 1a. Also totally differentiate 2. Okay, but at the same time you have to assume m over p is fixed. That means, remember, we want to look at what happens to output when G changes, because we're talking about fiscal policy. So we don't talk about monetary policy. There's no change in money supply, therefore. So we have to assume real money supply here fixed. We totally differentiate 2. It becomes d means change, m over p naught constant, and then equals to, totally differentiate on the left hand side. Here it becomes delta L over delta R plus delta K or kappa over delta Y. Oh, I forget one thing here. Let me fix it. Should be something missing here. Multiply by dr plus delta kappa or K delta Y times dy. And remember, we assume real money supply is fixed. Therefore, you look at dm over p. This one means change, so there is no change. So what's the value of d of m over p when money supply is fixed? When there is no change, then this one you should equate it to 0. That means the whole thing here equals to 0. Okay? Once you have this, rearrange it mathematically like what we did previously. You are going to get dr equals to minus delta k over delta y over delta L over delta R times dy. Let's call this one 1b. Alright? Now what do we need to do here? We need to combine these two, 1a and 1b. How do we combine it? You look here, dr equals to the whole thing here. Okay, so if you look at 1a here, the total differentiation that you made, do you see any dr here? Yes, dr is here. So we need to substitute 1b back into 1a and then rearrange it so that we can get government spending multiplier. Yeah? So we proceed with this. Substitute 1b into 1a yields the following. So we have dy equals to delta c over delta y in bracket dy minus delta tau over delta y dy in it plus let's look here, di over delta I over delta r, delta I over delta r times dr, but this time dr becomes this minus delta k over delta y over delta L over delta R times dy plus dg. That's it. And you rearrange mathematically. There are some process here that I won't show you, but you must do it on your own because I'm not teaching you maths. I'm teaching you macro. Bring left to the right, right to the left. Must be at your fingertips now. Yeah, master student. Then after you rearrange it, you should get 3. If you look here, dy equals to the square bracket, the term in the square bracket here multiplied by dg. And if you bring dg to the left, then you can get this. So what is this? What it's trying to say? It says if there is an increase in government spending, income will increase by the whole of this. Okay, now let me erase the mess. If you could remember, I erase this because I cross multiply it to the left. Yeah, I mean dg. I erase dg because I cross multiply it to the left. Alright, now 1 over something here. We have, if you look at the denominator here, this is the first term, this is the second term after the plus sign. The first term is not something new. You have seen it in previous chapter, isn't it? And the first term here is nothing else but, like I said in the previous chapter, is 1 minus MPC. which is MPS, nothing new. But the second term here, you can see this term. This term exists because we incorporate money market. When we incorporate money market, we incorporate LM. When we incorporate LM, we incorporate, the effect of R on the components of AD, or aggregate expenditure, or IS, and also the effect of R on money market and how it can affect, AD or AS or IS. You get what I mean here? So this is where we have, interest rate. Now if we try to go back to this graph and relate it with that equation, this equation. Now let me erase the mess first so that it doesn't look so messy to explain everything here. Yeah. Let me redraw the graph here in this page, but roughly. So you have Y, interest rate, and then you have IS not with initial G, and then you have LM with current, existing money supply without change, and then the existing is E here, Y not, R not. And then, like I said earlier, let's say there is an increase in G from G0 to G1. So G1 minus G0 is equal to change in G. And this change in G is referring to this. What happens to income? If you take the ratio, it becomes 1 unit change in G leads to how many units of change in Y. You get what I mean? Because when you take the ratio, you take the average. Okay, now, so we know that because G is a direct component of IS, IS will shift to the right from IS0 G0 to IS1 G1. If, interest rate hold constant, like I said, we come from income can increase from Y0 to Y1. And it is denoted by this bit. Okay, it increased by the amount of multiplier. So here, let's say change in Y equals to Y1 minus Y0 is actually equivalent to dg times 1 over 1 minus delta C over delta Y blah blah blah. Okay, this bit only. But now, because we are incorporating, interest rate, Y0 to Y1 won't happen. If you allow it, then you have disequilibrium. Because it won't happen because of disequilibrium, then adjustment takes place. So this one is not used anymore, but instead you have to incorporate this on the denominator of your government spending multiplier. So what happens next? So Y0 to Y1 is this bit, and then, okay, E prime. From E prime to E double prime is because of this. How to explain it? Okay, let me erase the mess, yeah. In this case, from E prime to E double prime, remember, interest rate is allowed to adjust. Because government spending increases, needs borrowing, and borrowing, the cost is interest rate, so interest rate will adjust. And because private investor also invest, and the cost of borrowing is also interest rate. And you remember the relationship between investment and interest rate is negative. So that's why we have here. So when interest rate increases, investment decreases. That's why you can see when interest rate increases, when investment decreases, output has to decrease this bit. And at the same time, okay, this bit is basically the response of money market towards the change in interest rate, towards the movement of interest rate, increase in interest rate from R0 to R1. when interest rate increases because of this, increase in government spending, what happens in the money market is that you see here, this is a change in money demand due to income, and this is change in speculative money demand due to interest rate, isn't it? And it has negative relationship. So when interest rate has to increase, the adjustment takes place along LM curve movement from E to E double prime, and that movement is denoted by this red thing. How can you explain this red thing in detail with this movement? What I want you to do is to read the textbook to see the details. Yeah, I want you to see the details. Okay, I may ask you in the exam or in the quiz or in the assignments. I mean in the quiz or assignments. Yeah, so please look at this in detail. So what I have explained to you is about 75% of economic intuition of expression 3. Now, okay, let me clear the mess. So here, if we don't incorporate interest rate, then there is no change in interest rate, isn't it? Interest rate will maintain at R0, like what we did for the previous chapter. If interest rate is maintained at R0, then DR is 0. Okay, go back to this. When DR is 0, the whole thing here is 0. When the whole thing here is 0, if you rearrange it, that means this thing will be 0, isn't it? Because no change in interest rate means investment is not affected by interest rate. Okay, and because of that, expression 3 that we have here will reduce to expression 4. Have you seen this expression 4 earlier? Yes, you have seen it in the previous, chapters. And can you compare the economic intuition of the difference? Compare the economic intuition of the difference between expression 3 here and expression 4. It's very obvious that expression 3 we incorporate interest rate, but in expression 4, which you have learned earlier before this chapter, does not incorporate interest rate. In addition to calculation of government spending multiplier, we also want to look at how effective is fiscal policy. And let's say we still use government spending, and we can explain this by having this graph. So we have interest rate here and we have real income here. Let's say we have 3 different segments of interest rate. Let me draw it properly. So we have 3 different segments of LM curve. And the first segment is a flat segment, the second segment is a upsloping segment, and the third segment is a vertical segment of LM curve. And let's say we talk about the flat segments, and initial IS is here. Okay, IS naught, and initial equilibrium is this. Why not? So if government spending increases, of course you know that it's a direct component of IS shift to the right and blah blah blah. Cut it short. And then you can see output increases from Y0 to Y1. But let's say we are in this region. I changed the pen color here. IS0. And we shift it by the same amount of shift, for instance. let's say this much. IS0 to IS1. So initially, why not red? If interest rate is not allowed to change, maintain at R0, and maintains at R0 here. And then y0 to y1 is just equal to y0 to y1 of black here. Y0 to y1 distance in red color is just equal to y0 to y1 distance in black color here. But because we are in the upsloping range of LM, in which the higher the output, the higher the interest rate, and vice versa, and adjustment takes place because of crowding out effect, then you can see the increase here is not up to y1 but only up to, let's say, y1 prime red. Alright, so let's say I change the color because I want to talk about the third segment, and I have it green. Let's say the initial one is here, so this is IS0, and it shift by the same amount, let's say this much, to IS1. You can see here, if interest rate is allowed to be constant here, let's say R0 green, then output increases from y1 prime to y2, the same distance as this, and also red y0 and y1. However, because it's a vertical, interest rate increases and it's 100%, vanishes the increase in income because of the increase in interest rate here. So different segment gives you different results. And does these three segments really occur in reality? Right. The first segment here, the flat segment, occurred during Great Depression. During Great Depression, the issue here is this. When people have a bad recession, no matter how cheap is the cost of borrowing, investor cannot borrow money, cannot produce goods and services, cannot sell it back to the consumer because consumer cannot afford to buy. Everything seems so, so like no future. And because of that, we also have what we call the issue of liquidity trap as well. Okay, and try to figure out the meaning of liquidity trap here, because this one has been introduced during undergraduate level, and how to explain it also. But in the upsloping range, you look at the red color of IS curve, where LM is upsloping. Look at the black LM here, this one. It is upsloping, isn't it? Increase in government spending leads to increased adjustment in interest rate, leads to crowding out effect, and the impact on the output is increased but not as much as before. And that's why during Great Depression, in the flat segment here, we go back to the flat segment here. In the flat segment here during Great Depression, Keynesian says it's better to have intervention by the government, because when interest rate increase in interest rate, it doesn't give impact on doesn't give impact on capital to be lent out. People are not motivated to do business. Government has to take initiative to intervene, to start the project and whatnot, so that others will follow suit, because it has been found based on Keynesian that output can increase by the full amount of multiplier. But in the upsloping range, in the normal circumstance, Okay, it's very normal to see when government spending increases, borrow money, there will be some other, investor cannot borrow because they bid up the price of the money, which is interest rate, the price of borrowing, sorry, the cost of borrowing, which is interest rate. So some investor will be crowded out. That's why we have crowding out effect here. So because of that, the net increase in output is only between Y0 to Y1, not between Y0 to Y1. But when we have vertical range here in which interest rate increase 100% eliminates the whole increase in income due to increase in fiscal policy, then you can see that fiscal policy is not very effective. The most effective range of fiscal policy is when LM is flat. And Keynes always believed that during Great Depression, LM curve is flat. That's why we have liquidity trap. Okay. The second effective is when LM is upsloping, but the least or no effect at all on output for fiscal policy is when LM is vertical. So here you can see that the effectiveness of fiscal policy depends on interest elasticity of the LM curve. For interest elasticity at the flat segment here, it is very, very highly interest elastic. For upsloping, it's also interest elastic, but not as high as the flat segment. But the vertical one is very perfectly interest inelastic. So when government gives increased government spending, it doesn't give any benefit at all, isn't it? Try to read a lot on this, the effectiveness of fiscal policy. Read the textbook on the explanation. You can find a lot of vocabulary to be used to explain this economic intuition. Yeah, so I hope you read the textbooks as well. So we are done with the first two, which is government spending. You can try to decrease government spending and see what happens to the fiscal policy and also economic output, and make sure that you know when is the right time to use decreasing government spending for fiscal policy and what's the name of fiscal policy when government spending is reduced. Yeah, so now let's move to the next one. We want to look at the changes in tax, and this time around we want to make sure that a tax is not a lump sum tax, but the tax that depends on the level of income. And we know that from the previous chapters, if there is an increase in incomes, tax revenue will increase. So it has positive relationship between income and also tax. The same as fiscal policy analysis for government spending as a tool, we want to look at, if there's a change in tax, income tax, what happens to equilibrium output, what happens to equilibrium interest rate. So let's assume that income tax is proportional to the income received, that is expressed in expression 5. Okay, if we try to put it in the form of graph, I use ISLM. R is here, output is here, we have IS naught, we have LM. Initial equilibrium is at R naught, Y naught of interest rate and output respectively. At LM naught, we have real money supply at price naught. So this is A, for instance. Now my question is, we're still talking about the fiscal policy. Any change for money supply here? No. So money supply here is fixed. Okay, the real money supply is fixed. Okay, now again, in terms of graph, just imagine if there is a decrease in tax, what will happen next? Remember, tax is a function of income. Okay, what you learn in your first degree or bachelor degree, decrease in tax leads to increase in income or disposable income. And then after that, it affects your consumption and saving. You see here, consumption will be affected in such a way that consumption will increase. But would it increase by the same amount of increase in income? No. When there is an increase in income, you don't use all of the income, the increase in income for your consumption. Some of it you keep it. You get what I mean? So the increase in consumption is by a certain amount, which is MPC amount. This is what you learn in the undergraduate level. And when it increases by MPC amount, then you can have increase or change in C equivalent to MPC times change in income, isn't it? Then you get, let's say, $5 or whatever dollar you have. Okay, depending on the MPC value and the change in income here. So for instance, let's say this doesn't happen. So I'm just making up here. I'm going back to undergraduate level. If there's an increase in income by 10, how much consumption will increase if MPC is 0.8? So here, 0.8 times 10, $8, isn't it? That's what it means. Okay. Now, because tax here, you can see affect consumption indirectly via income. And you know that consumption is a direct component of IS curve. Then what happens next? Reduction in tax leads to increase in disposable income, leads to increase in consumption. So IS curve will, in the first place, in the first stage, will shift by the amount of MPC times change in Y. So let's say here, okay, IS not prime. And after that, okay, and then the next step is increase in change in C by 8, increase AE, and then increase output because you need to produce this much. Also by 8, and then after that, in the next stage, change in consumption equal to MPC times what? You get what I mean? Yeah? So the first stage here increases 8. The next stage is what? And so on and so forth until the last stage, until the last, line or the last, the last stage. So finally, you can have a total increase in IS from IS0 to IS1, and this, if interest rate is constant, Y0 to Y1, the change in income here is actually equivalent, is due to, change in tax, reduction in tax times tax multiplier, isn't it? That's what you learn. But because we want to incorporate interest rate, then adjustment takes place from E here to E prime to E double prime. Then interest rate increases and then output only increases up to Y2, for instance. Now my next question is, do you think that the final change in income, which is this between Y0 and Y2, due to decrease in tax, remember, if we have this kind of fiscal policy, expansionary fiscal policy, the distance here is similar to the distance here, and in this case it is due to change in G. Remember, G is a direct component of IS. So if G increases by 10 in the first stage, income also increases by 10. But for tax case, if tax decreases by 10, income increases by 10. But consumption increases not by 10. Consumption increases less than 10. You get what I mean? And consumption is a direct component of IS. So what do you think? Would it be the same? I mean, the change in T, would it give you the same amount of change in income? Like the way we have the change in G. That's the thing that you need to figure out, yeah? Okay, so I hope you can figure it out. Now, so you want to look at the the multiplier for changes in text. Again, like I said earlier, we need to assume that text is a function of income. Because we want to incorporate interest rate, we're going to use ISLM model also. Okay, so now we have fiscal policy, expansionary fiscal policy. Let's say we have tax now as a function of income. Specifically, now we have expansionary fiscal policy. If we have expansionary fiscal policy and we want to use tax, we have to reduce tax. Let's say initial tax is T0 reduced to T1. Therefore, we can have T1 minus T0 equivalent to the change in tax, isn't it? Right. Now, and also we want to find the multiplier for changes in tax from T0 to T1, and we want to see what happens to equilibrium income and also equilibrium interest rate. Therefore, we need to incorporate interest rate in the model by having IS and LM, because in IS you can see interest rate affects investment, in LM you can see interest rate affect the speculative demand for money. Okay, so what should we do? As usual, totally differentiate one. Okay, and then you get dy equals to delta c over delta y dy. Okay, this one you have to be very careful. You look here, delta t delta y dy plus di over dr plus dg. I call this one 1a. Okay, now for this 1a, we have assumption we don't use government spending, so we don't change the government spending. Because we don't change the government spending here is constant, and therefore this dg refers to the change is 0. And what we need to do is we need to specify 1a even further, because this is delta t or tau over delta y times dy, isn't it? And we know that, okay, t is a function of y now, so we specify it this way. You look here, dy is therefore can be written further as delta c over delta y in bracket dy minus, okay, you look here carefully, we have this, we want to differentiate it specifically using product rule. Okay, so remember the initial tax is T0, the change in tax is basically T1 minus T0, isn't it? So we are going to use this notation for the differentiation here, and this is a generic form only, not a specific one, but because we know that tax is a function of y, and that's how we do it. We have initial tax multiplied by the change in y. Let me put square bracket first. I'm doing total differentiation for tax here, plus, okay, initial y and change in tax. Can you see? First, I totally differentiate y. I put tax, initial tax constant, plus I make y constant, and then totally differentiate tax becomes dt in the bracket, and then close bracket, and then plus delta I over delta R. What about this? I don't have to rewrite it again, because dg is 0. Remember the assumption. Now I can expand it even further and rearrange it nicely. Then I can have this delta c over delta y. in bracket, this is just a simple maths, yeah, 1 minus tau naught dy. Okay, you should know how to do this. This is just simple calculus. Minus delta c over delta y times y times dt plus delta I over delta r times dr. Okay, so this is 1b, 1c. Alright, that's how I level it. So I'm done with IS. Now I need to totally differentiate 2. So totally differentiate 2. We have what? It's just similar to the thing that we have done earlier. Not D. Okay. So D m over P naught m constant equals to 0 because we don't have any change in money supply on the money market side. We are doing fiscal policy. Okay. And then equals to delta L over delta R times dr plus delta K over delta Y times dy. Call this one, let's say, 2b. Okay. Rearrange it. Rearrange to b to get something like this. So you have dr equals to, I'm sure you know how to do this already, over dl over dr delta, dy. I call this one 2b. Substitute 2b into 1c. Why? Because in 1c, let me use a red pen, you can see dr. In 2b, I have dr. So substitute it back into 1c. So once you substitute it back into 1c, you are going to get this dy equals to delta c over delta y. We write this again as usual, times dy minus. Okay, this is something that we bring forward from the previous, expression, delta c over delta y times dt plus delta I over delta r times, okay, minus dk over dy over dl over delta k over delta y over, don't forget minus sign, delta l over delta r times dy, close bracket. And I call this one, let's say, 2c. And after that, you rearrange them nicely. You have some stuff here that you need to show, but I won't show it to you. You have to do it and you have to show it. Okay? And you rearrange them until you get this one. Okay? Until you get this one. So you have on the left hand side dy, on the right hand side, you look at the numerator, minus delta c over delta y times y. The whole thing's here times y. That's how it works. Okay, and you have on the denominator as usual this and this, and then multiply by dt. If I erase this, I bring it here, and then if there is an increase in tax, income will decrease by this much, the whole square term here. So rearrange them until you get expression 6 here. Now the next thing that you need to know is how to explain the results, how to explain the economic intuition behind this result. Okay, as you can see, this is on the IS side and this is on the LM side, or on the money market side, right? And this is the impact of tax on consumption. Okay, and the whole thing here is tax multiplier. My question here is, we have tax multiplier in 6 here, in expression 6 here, and we have government spending multiplier in expression 4, not this one, but this. I'm referring to 3 instead of 4. So let's say we have increase in G by 10 in expression 3. We have decrease in T by 10 for expression 6. For expression G, what will be the increase in Y? For expression 6, what will be the increase in Y? Will the increase in Y here will be the same as increase in Y here, although the amount of increase in G is equal to the amount of decrease in tax. So we have expansionary fiscal policy, but the first one using government spending, the second one using tax reduction. Would both of them give us the same results of change in tax? Can you figure it out? And if you say yes, how do you justify using this expression and also expression 3? Compare expression 3 and 6. If you say no, how do you justify it using expression or equation 3 and 6? I want you to do that. Alright? Now, we still talk about fiscal policy, but this time we want to get balanced budget multiplier and the money market. What does it mean here? In the previous chapters, we have seen and we have derived this balanced budget multiplier, which is in expression 7 here. So you see numerator, you cancel this, then change in Y is equivalent to change in G. That's why, cross multiply, you can get balanced budget multiplier is actually equivalent to 1. Okay, but here we don't incorporate money market, so you can't see interest rate here. We want to figure out whether we can have balanced budget multiplier equals to 1 or not when we incorporate interest rate, or in other words, when we allow money market to be in the system. So basically we try to make it becomes closer to reality. Yeah, all right. So as usual, we need, because we want to incorporate money market, and so we want to incorporate interest rate, we need to use ISLM equation to derive this multiplier. And what does it mean by balanced budget multiplier? I didn't mention to you in the previous chapters, but it's basically the increase in government spending is fully financed by the increase in tax by the same amount. So it leads to increase in income. For this case, for 7 here, the increased income will be the same as increase in tax and also G. That's why you have balanced budget multiplier equals to 1. But if we incorporate interest rate and also money market, would it be the same? That's the question. So how do we do it? As usual, we need to have equation 1 and equation 2. Equation 1 is basically as usual. The ISLM here. Okay, so we need to totally differentiate both of them. But this time, before we can totally differentiate both of them, we need to make certain assumption on tax. Why do we need to make certain assumption on tax? Let me erase this first. If you can recall about the balanced budget multiplier that we have in the previous chapter, we have assumption tax is a lump sum tax, and tax is a lump sum tax, so it does not depend on Y. This time around, we want to have money market here. We also want to have the same kind of tax as previous balanced budget multiplier derivation, in which tax is a lump sum tax. Okay, and so that after we derive balanced budget multiplier, when we have money market, we can always compare with 7. Okay, we want to compare with 7, so we must have certain base or assumption which is the same, and in this case we want to have a lump sum tax. All right, so I hope this is very clear. And also we want to fix the tax. Okay, so tax is constant. Okay, now we want to fix the tax here. All right, not that we want to fix the tax, basically we want to fix the change in tax by the same amount, otherwise it becomes very confusing for you to understand this when I say you want to fix the tax. But then when you see the equation after this, you can see the tax can change anyway. All right, so we want to have lump sum tax here. So you want to have the same change in tax with a G. That's the best way to explain it. You want to have lump sum tax, that's the assumption. Anyway, so let's proceed. Totally differentiate one, but this time tax is a lump sum tax. Okay, lump sum tax. We assume that it is a lump sum tax. So here, dy equals to delta c over delta y, and in bracket dy, you look here, dt, because this is a lump sum tax, and plus di over dr, delta I over delta r times dr. Okay, this is for investment, which is a function of interest rate, and then you have dg. Okay, so we call this as 1a. Totally differentiate to where m equals to m over p is constant, because we don't want to talk about the change in money supply, otherwise we are incorporating money supply in this analysis. So we fix the money supply. So when we differentiate, rearrange and whatnot, I skip the step, but you have to show it. Then you get something like dr equals to minus delta kappa over delta y, or delta k over delta y. This is a Greek letter actually, kappa, but I call it k for your purpose of understanding here. And then delta L over delta R times dy. Okay, so this is 2a, for instance. So what you need to do as usual, the next thing is you see dr here, you can substitute it back into dr here in 1a. So substitute, okay, dr into a into 1a. Okay, once you substitute it back there, okay, I won't show you all the steps, but you have to do it. This is just a matter of left to the right, right to the left, cross multiply. I'm not teaching you maths. You must know by now how to do all of this, that because the basic calculation you have learned in the high school, right? Now after that, what you need to do is you rearrange it until you get expression 8. Look here, until you get expression 8, and this expression 8 is not a balanced budget multiplier, because we haven't done another assumption here, so we need to have another assumption. So from 8 we can start impose balanced budget. Okay, we can start impose balanced budget, that is dg equals to dt. Okay, because dg equals to dt, look here, so this is dg, this is dt. So let's say instead of writing dt, I can write dg. Get me? Because increase in g is fully financed by the same amount of increase in t. That's what it means here, balanced budget. Impose balanced budget, and then What we need to do here is basically you can see common factor, which is DG. You can factorize it. I'm talking about the numerator, DG here, so you can factorize it. So it becomes 9. Can you see? We factorize it, then you can have in bracket 1 minus delta C over delta Y times dg and the rests. Okay, so if I cross multiply this, then I get dy over dg. Now we have 9 here. As you can see, if we don't incorporate money market, then you don't see this. You see this and this, you cancel this becomes 1, isn't it? And therefore it becomes similar to the balanced budget multiplier that we have in the previous chapter. But because we incorporate also the, let me erase the mess, this doesn't work well now. Okay, now it works. Because we also want to incorporate money market and also interest rate, then we have this bit in the denominator. So if this bit occurs in the denominator, what can you see? You increase G, let's say by 10. At the same time, you decrease T, let's say by 10. Okay, you think that income will increase by 10 also? 1 to 1 increase? Or is it increasing, does it increase, by less than 10? Will it increase by less than 10? Because of this investors and movement along the LM curve as well. How does it work here? So what I want you to do is to compare between 9 and also 7, which balance, because in 7 here, balance budget multiplier, if I bring a DG here, is equal to 1. But here, will this multiplier of tax here equals to 1 or less than 1 or more than 1? How to explain it? What's the reason you choose that answer? And you compare 9 with 7. Can we say 7 is greater? Can we say 9 is greater? Or can we say they are just the same? How to justify? So this is a homework that you need to do, yeah? So actually you can see the question here. Okay, that's the question that I want you to do at your own time. Alright, so that's it for a fiscal policy. Now we move to monetary policy. So here we are with monetary policy, the second types of government policy, economic policy. Now let us revise some basic of monetary policy. So how many tools of monetary policy and what are there? So if you revise, we have 3 different tools. Number 1, required reserve ratio, or in Malaysia we call it statutory reserve requirement, SRR. Number 2, we have open market operation, in which we have buying and selling government bond, only government bond for monetary policy. Number 3, we have discount rate. Now, which are the most commonly used tools? It is number 2, open market operation, of buying and selling government bond. Because if the central bank start to use number 1 and number 3, that means our country is in a very, very difficult situation, like what happened in the 1997, where we have economic crisis. So government used to reduce required reserve ratio, or SRR, and also discount rate. Now, required reserve ratio is actually a ratio or amount of liquid cash that must be held, in the central bank by every commercial banks. So it's like a saving of commercial bank in central bank, so that they don't use all of the money to loan out to others. So whenever they have difficult, always get back their saving from central bank. Okay, so but how it works basically, yeah. So required reserve ratio, you have to reduce it so that it affects your money multiplier. Money multiplier is a reciprocal of required reserve ratio. If you can recall back to the study, let's say required reserve ratio is 0.1, then you have money multiplier equivalent to 10. That means if you put one money as a first stage of loan, later the creation of money in the banking system will be $10, yeah, instead of one only. Okay, so if we reduce required reserve ratio from 0.1 to 0.05, of course money multiplier changes to 20. That means the money creation can even increase by double. And we also have open market operation. So usually if government wants to have expansionary monetary policy during inflation, okay, I'll be very fast on this because this is just revision. So during recession, what government will do is government will buy government bond from the public. So when government buys the government bond, it means government is lending out money to the public so that the money has more money supply, and they can create more money in the banking system by putting money in the banking system, creating more money supplies and more loan out, more investment, and so on and so forth. And discount rate is the interest rate charged by the central bank to the commercial banks if they want to borrow money from central bank. So if the discount rate is lower, they will borrow more and they can even invest more later, isn't it? So these are the tools. It's just revision. So if we try to put it in the form of graph here, I use IS and LM analysis. Then we have interest rate here, we have output here, down sloping IS curve and upsloping LM curve with current money supply MO over P naught. So current situation, interest rate equilibrium is R naught, Y naught here. Let's say point A. Now, when we have increase in money supply, LM will shift to the right. Okay, increase in money supply, given price is the same from M0 to M1. Then we have new equilibrium. You can see interest rate falls down from R0 to R1, sorry. And then you can see output increases. So how this happens basically, if you can recall back, LM shows you the equilibrium in money market. So we have quantity of money here, interest rate here. Money demand is always down sloping. Money supply is this one. Interest rate here, quantity of money here. Let's call this point E. So in expansionary monetary policy means increase in money supply here, and interest rate falls down from R0 to R1, money in the economy increases. So new equilibrium will be at E prime instead of E. So what happens here is that when money supply increases, okay, interest rate falls down. Okay, once interest rate falls down, if you don't adjust, then you may have disequilibrium here in money market. So money demand has to adjust. Because interest rate falls down, that means in money demand, we have transaction money demand and also speculative demand for money. So it will affect speculative demand for money. The money holder, the household will find that holding bond is no longer attractive because the earning of bond, which is interest rate, falls down. When earning of bond falls down, the price of bond increases, isn't it? So they would rather demand more money rather than bond because the interest earning is falling down. So that's why you can see movement along the money demand here becomes more and you reach to the new equilibrium. So that's why you can have new LM here at LM M1 over P naught here because of this movement. Okay, so that's why LM shift to the right. Now, consequently, when LM shift to the right, interest rate also needs to adjust. When interest rate falls down, in the product market, interest rate falls down from R0 to R1 means the cost of production for investor becomes cheaper. So they will borrow more, they will invest more. Now investment increases because investment is a direct component of IS. So we can see movement along IS curve because interest rate, movement along IS curve leads to increase in investment. Increase in investment, it leads to increase in employment. Increase in employment leads to increase in production. That's why you can have output growth here. So that's how it works in the form of graph. This is how you learn it during undergraduate study. But now our main interest is to know mathematically how it can be linked. We want to know if there is monetary policy, either expansionary or contractionary fiscal policy, what happens to equilibrium income, what happens to equilibrium interest rate. And then we can also analyze it in the form of maths here. That's why we need to come up with what we call multiplier for changes in money supply. So we're going to look at that in a bit. Okay, so we want to come up with a multiplier for changes in money supply to depict the monetary policy. Okay, let's say we have expansionary monetary policy, for instance, and here we try to put it in the form of mathematical equations. So we need to define real money supply, in which real money supply is the division between nominal money supply and also price level. Now, what we need to do is that we know that we have LM equation. Okay, this is LM equation. We need to substitute 10 back into 2 here to obtain 11. So it's nothing else because usually we have M equals to this. Okay, that we just need to be more specific, that's all. Okay, now, so here again, because we want to come up with multiplier for changes in money supply, we want to see what happens to equilibrium income and also interest rate. So we need not only 11 LM, this is LM, we also need IS, so that we can always see what happens to output. So what do we need to do here is that, okay, let me rewrite again. So IS relation is basically this, y equals to this plus I plus G. So this is equation 1. And then equation 11, this, okay, equals to this and this. So this is equation 11. Okay, let's say currently money supply fixed, but now I'm going to change it. So what we need to do is to totally, as usual, we need to totally differentiate IS, and then after that, totally differentiate LM in equation 11 here. So let's begin. I would show you all the steps here. You need to do some calculus here because those calculus are basic that you have learned in the high school. Bring left to the right, right to the left. Okay, so totally differentiate 1. So we obtain dy as usual, yeah? So by now, you should know how to do a total differentiation. And for IS here, because we talk about monetary policy, we are not talking about fiscal policy. So we have to assume G is fixed. When G is fixed, what happens to this value? It becomes 0, isn't it? Now I call this one 1A. So this one would exist, yeah? Next, we need to totally differentiate 2. But at the same time, money supply can change. Last time we fixed money supply, but this time we can change it. So if we totally differentiate it, following, look carefully at the way I totally differentiate it, because this time money supply can change. So dm because change in money supply is no longer equal to 0, isn't it? Because usually we equate the change equals to 0 is equal to change in nominal money supply. We are not talking about the change in price. The price stay the same. Okay, equals to as usual. Okay. Okay, so let's call this one 11A. Now we call this one 11A. Now the next thing is, what you need to do with 11A is you need to rearrange 11A such that the R is on the left hand side and the rest is on the right hand side. So when you rearrange it, you're gonna get something like this. You look carefully. So we don't use this one, we use DM. Okay, we use DM equals to the rest here. So after rearrange it, we're gonna get DM multiplied by delta R over delta L minus delta K over delta Y times delta R over delta L times dy. Okay, I call this one 11B. Now, from here to here, I don't show the step, but you must figure out the step. Is it clear? Don't miss this step. Here, it becomes a homework to you. In the assignment, you have to show it also. Now, what do we need to do next? As usual, once you found DR, you substitute it back into total depreciation of IS, which is 11A. So, when you substitute 11A back into 1A, it will give us something like this. dy, this is just substitution, yeah, this over delta C over delta Y, dy minus delta T over delta Y dy, okay, and then plus di delta R, okay, bracket, we substitute it with this. Okay, all right. Now I call this one 1B. Now, once you have this, you must rearrange carefully until you get expression 12. So when it comes to rearrangement, cross multiply and whatnot, I don't do anything here. I don't show it. This is not the level of master. This is the level of, maths during high school, going to the left, going to the right. Let me give you some hints here. In between, in the last line, before you get the final answer, try to multiply both sides. Okay, multiply both sides with this. Delta L over delta R divided by delta L over delta R, both sides of equation, left hand side and right hand side, and then after that you will see, you will get something like this. Okay, so I already gave you the hint. The rest you must do it. In fact, yeah, if I were to tell you, when I studied my master, what my teacher did was, he just say, okay, totally differentiate 1, totally differentiate 2, and then rearrange until you get this. He won't show exactly this way. We had to figure it out. Why? Because the maths here is not the master level of maths. It's the high school level of maths. Alright? So now, once you get the answer, which is this, the next question is how to, interpret these results. Remember, G is fixed because we don't talk about fiscal policy, we talk about the change in money supply, monetary policy. So if there is an increase in money supply by 1 unit here, then income will increase by how much? By the value in the square bracket here. That's the simplest way to interpret it. But then, we are not really care about this because this is a very basic interpretation. But we really care about because multiplier here means if you inject 1 unit of money, the outcome is increased in the output by the multiple amount. Okay, the effectiveness of this multiplier is questioned. So because we want to see how effective is the increase in money supply in increasing income. So we want to look at the effectiveness of monetary policy. And there are two ways to explain it. The first way is, of course, undergraduate level of method. And the second way is, of course, higher level method here. So if you look here, we try to put it in the form of graph. So we have interest rate here, price here. The effectiveness of monetary policy in terms of graph, you have seen it during your undergraduate study. So let's say this. Okay. And let's say we have about almost 3 different segments, like I said in the previous slides. So let's say initial IS is here. So output is here. Initial interest rate is here. Just imagine if we have expansionary monetary policy, that means basically LM will shift to the right, isn't it? If the economy is in the flat region of LM, how LM shift to the right? It will be like this. Let me use a different pen here. Okay. There you go. And then this one is the new LM. Okay, let me change the color so that I can write it properly. So this is the new LM. Okay, money supply increases, LM shift to the right, but only on the upsloping range or on the vertical range. Because the shift is only on the vertical range, if the economy is at this point A, with current output in recession, so the expansionary monetary policy is not working well, isn't it? Because no change in output here. You see the purple line here stay the same and interest rates stay the same. So this is the issue of liquidity trap, in which we hope that increase in money supply could reduce the interest rate, but the reduction in interest rate is very marginal up to the point that it doesn't move higher, but it moves lower like this a little bit. In the because we increase monetary policy here, increase money supply just to have lower interest rates so that cost of production decrease in the hope that investment will increase. But this is not the case at point A here, because we are facing flat LM curve, and increasing in money supply does not decrease more interest rate to attract enough investment. In fact, during liquidity trap, if you read a lot of theory and also history, even if interest rate falls down a little bit like this, okay, nobody wants to invest. Nobody wants to invest more. It doesn't happen. In fact, they use instead of investing, they channel the money towards saving. They increase saving, but they don't use it for investment. So production doesn't work. No employment increase, and then output stay the same here. So you're trapped here. You get what I mean? But if let's say current economic situation is here with IS and with LM and IS1. Okay, and current interest rate is here R1 at point B equilibrium, and why not? When the government wants to have expansionary monetary policy, increasing money supply, shift the LM to the right from LM to LM prime here on the upsloping range, you can see clearly it shifts, it moves, then the new equilibrium will be achieved somewhere here because the line of the drawing is too thick. So R2 interest rate falls down, the cost of production decreases, leads to the motivation of the investor to invest more, and then hire more labor. And then, of course, with that, production increases, output can increase, economic growth. Then you can see the effectiveness of monetary policy works well when LM is steep. But when LM is flat like this, the effectiveness is little. So let's say the shift in LM, let's say LM here, let's say shift a bit like this. So the interest rate falls down only a bit. You get what I mean? So it's not effective at all. Alright, so here in this case, can you try to study more about the liquidity trap? Now, the explanation here is using graph, not mathematics. So at your level, we need to have mathematics explanation, okay? Because we want to see how multiplier can be used to explain this scenario. So like I said earlier, the effectiveness of monetary policy here depends on the LM curve, whether it's flat or steep or vertical or whatever it is, yeah. So that means the effectiveness of monetary policy depends on the interest elasticity of LM itself and money demand, speculative demand of money. All right. So what I'm going to do is to talk about this money multiplier in relation to the elasticity of LM itself. And if you can recall back, okay, the slope of LM as shown in the previous chapter, okay, the slope of LM is this, dr over dy equals to minus delta k over delta y over delta L over delta R, and because this value is negative, negative makes negative positive. That's why your LM is upsloping. Okay, now, and if you recall back the study during undergraduate level, the slope of LM, okay, let's say this R, this Y, it can be like this, it can be flatter, it can be even steeper, because it depends on the interest elasticity of money demand. And interest elasticity of money demand can be measured by this. You look at interest here. This one is income. This one is interest. Interest elasticity from the speculative demand of money. Okay. So here, how slope of LM can affect money multiplier? It is depending on the interest elasticity of money demand. And interest elasticity of money demand again being measured by the one in the denominator here. Let's look at the first instance. Number one. If, remember this is interest elasticity of money demand here. If delta L over delta R itself, okay, approaches zero, this is in mathematical sign, it approaches zero, what will happen to the slope of LM? So that means, let me erase this. That means the value here is almost zero, isn't it? When the value here is almost zero, then the slope of LM, which is dr over dy, approaches infinity, isn't it? When it approaches infinity, y, LM means the slope is approaching infinity, become very huge, very steep or very flat, very steep. Just imagine if the slope is 1000, not even infinity, very steep, like this. You get what I mean? Yeah? So we look here, what is the implication on money multiplier here? So money multiplier becomes what? So you look here, delta L over delta R, okay, approaches zero. So the whole thing here approaches zero also, isn't it? Then money multiplier becomes dy. Okay, if I cross multiply here dm, then I have delta I over delta R over 0 plus d delta I over delta R times delta K over delta Y. So what happens here when one of the value on the denominator becomes 0? The whole value increases, mathematically speaking, isn't it? And the whole value increases. That means the money multiplier becomes bigger or larger. So that means the steeper the LM curve, because of the higher interest, the very inelastic, uh, interest elasticity of money demand here, when it approaches 0, means very inelastic. Then LM becomes steeper. When LM becomes steeper, money multiplier becomes more. When money multiplier becomes more, it means if we put $1, increase $1 money supply, output will increase more than this multiplier, and output will increase by this amount. And this amount is bigger than this multiplier. You get what I mean here? Right? So that's why you can see, go back to this graph. This is steeper, isn't it? This range is steeper, LM, this range is very flat. That's why you can see output can increase because money multiplier is bigger. Now, what about if we have flatter LM? In other words, the interest elasticity of money demand is very elastic. Okay, the one that we have initially here, the story here, we have inelastic money demand. That's why delta L over delta R approaches 0. Okay. Now, let me use a different color of pen. Okay, so that this story I can change, you can always compare. Let's say if delta L over delta R approaches infinity instead 0. So what happens to the slope of LM, which is dr over dy? This is not 0. It approaches infinity. Denominator is infinity. Numerator, you still have some integers here or number. Any number divided by infinity, the slope will be approaching 0. So, dr over dy, which is the slope of LM, approaches 0. Okay, can you see the difference now? Now, what's the implication on money multiplier? Alright, the money multiplier, look at this. So, you want to see what happens to money multiplier, yeah? The delta L over delta R approaches infinity. Let me use, I'm using wrong pen, otherwise you get confused. See, this one approaches infinity. And then, look at the denominator before plus sign. This is plus sign. This one, the whole thing becomes infinity. So, money multiplier here, instead of 0, this bit becomes infinity. Okay? So, the whole thing here becomes infinity. I mean, the whole denominator approaches infinity. Denominator approaches infinity, the value here obviously very small, and then multiplier decreases or becomes smaller. So here, because LM is flat, okay, how do we know? Because the slope is 0, approaches 0. Because LM is flat, the impact on multiplier will be smaller, isn't it? So can you see, when LM is flat, because the interest elasticity of money demand is very elastic, this one. Interest elasticity of money demand is very elastic, LM becomes flat. Look at the red, yeah? Because the slope becomes zero, slope of LM becomes zero. And then money multiplier as a whole becomes smaller. What does it mean when money multiplier becomes smaller? If you put $1 or £1 of money supply increase, the change in income, which is this, is very, very small. That's why when LM is flat here, in fact, there is no change in income because it's too small. Alright? Make a summary so that you can see the link. Number one, when you talk about money multiplier with the effectiveness, you look at this. What is this? This is the interest elasticity of money demand. Why? Because basic, intermediate, macro, yeah, the interest elasticity of money demand affect the slope of LM, which is dr over dy. After that, then only we talk about what happens to money multiplier. Okay, so this is how it is explained using maths. Okay, so let's recall back the fiscal policy. Fiscal policy here, the effectiveness of fiscal policy also depends on the interest elasticity of LM curve itself, which is delta L over delta R. Okay, so you try. What happens if delta L over delta R approaches 0? What happens to, and dr over dy. This is the slope of LM. And then what happens to the fiscal, government spending multiplier? Because the effectiveness of fiscal policy depends on the slope of LM in this case. Okay, so look at the slope of fiscal policy, which is this is not actually, which is this. Okay, right. Yes. And what happens to that? So do it as your exercise. So this is how we talk about introduction to monetary and also fiscal policy at your level. We use a lot of mathematics. Now, let me give some summary so that you can see clearly what you need to know in this chapter. Number one, you need to know the basic. When I say you need to know the basic, what are the tools of fiscal policy? What are the tools of monetary policy? Number two, you need to know, okay, what happens if we have expansionary monetary policy by increasing G? What happens to equilibrium output? What happens to equilibrium interest rate? If we have decrease in T, expansionary fiscal policy, also what happens to equilibrium output? What happens to equilibrium interest rate? On the other hand, if we talk about monetary policy, you need to know the tools, the three tools. Okay, I won't repeat it again. You have heard it in the earlier slides. And all of these three tools, if you have expansionary monetary policy, obviously will increase money supply. What will the effect on ISLM? Okay, how the effectiveness can be discussed, I have shown you. Right? So that's all for chapter 5. Thank you.